Imagine a creature that can survive being frozen solid, boiled alive, or even blasted with radiation. What if I told you these aren't sci-fi fantasies, but real organisms thriving right here on Earth? Prepare to have your mind blown as we dive into the incredible world of extremophiles and uncover the secrets to life's ultimate resilience. Forget everything you thought you knew about where life can exist. We're about to explore the most inhospitable places on Earth, where life doesn't just survive, it flourishes. From scorching volcanic vents to bone-chilling polar ice, discover the unbelievable adaptations that push the boundaries of what's possible and make us rethink the potential for life beyond our planet. Life on the edge. What does it take to survive the harshest environments imaginable? Join us on an epic journey to the very edge of biological possibility, where life defies logic and thrives against all odds. These aren't just fascinating organisms, they hold the keys to understanding fundamental survival principles and might even reveal where we could find life in the cosmos. Are you ready to see life's true grit? What is an extremophile? Most life on Earth, including you and me, is actually pretty picky. We like it not too hot, not too cold, with plenty of oxygen and mild radiation. We are mesophiles. But then, there are the rebels. The extremophiles. The word literally means lover of extremes. These are organisms. Mostly bacteria and archaea, but some animals too, that thrive in conditions that would kill a human in seconds. We are talking about environments with pH levels akin to battery acid, pressures that would crush a submarine, and temperatures that melt lead. So, how do they do it? Let's break down the big three of survival: the heat, the cold, and the indestructible. Into the fire, thermophiles. First stop, the bottom of the ocean. Here, superheated water blasts out of the Earth's crust at temperatures reach over 400 degrees. This is the home of the hyperthermophile. Usually, high heat breaks the chemical bonds that hold proteins together, like cooking an egg white. But organisms like strain 121, named because it survives at 121 degrees Celsius, the temperature used to sterilize medical equipment, have evolved proteins with incredibly tight cores and heat-resistant clamps. They don't just endure the heat, they need it. If you brought them up to a comfortable room temperature, they would actually freeze to death. The deep freeze, Psychrophiles. Now, let's flip the thermostat. Welcome to the world of Psychrophiles. In the freezing tundra or deep within glacial ice, water turns into sharp crystals that puncture cell walls like microscopic daggers. So, how does life survive here? Antifreeze. They invent their own antifreeze. These organisms produce cryoprotectants, special proteins and sugars that lower the freezing point of water inside their bodies. It prevents ice crystals from forming, keeping their insides liquid even when the world outside is frozen solid. Some bacteria have been found dormant in ice cores that are over 100,000 years old. When thawed out, they woke up, they went right back to work. The indestructible, tardigrades. But the undisputed champion of extremophiles isn't a bacteria. It's this microscopic, eight-legged tank, the tardigrade, also known as the water bear. Their secret weapon is called cryptobiosis. When things get tough, like total dehydration, they curl into a little ball called a tun. They expel almost all the water in their body and replace it with a glass-like sugar. In this state, their metabolism drops to 0.01%. They are essentially dead until you add water. Then, decades later, they pop back to life. Space footage. The ISS. In 2007, scientists strapped these guys to the outside of a rocket and shot them into space. They were exposed to the vacuum of the void and deadly solar radiation. 10 days later, back on Earth, they were fine. Some of them even laid eggs. The cosmic connection. Why does any of this matter to us? Because if life can survive in a volcano or deep under the Antarctic ice, the definition of a habitable zone in space just got a lot bigger. Take Europa, a moon of Jupiter. It's covered in ice, but beneath that crust, we suspect there is a liquid ocean warmed by tidal forces, very similar to our deep-sea vents. Because of extremophiles, we know that life doesn't need sunlight to exist. It just needs energy and chemistry. Studying these creatures on Earth is our practice run for finding aliens in our own solar system. From the boiling depths to the frozen poles, extremophiles teach us one undeniable truth: life is stubborn. It is resilient. And it is far more creative than we ever gave it credit for. If biology can find a way to thrive in the battery acid of a cave or the vacuum of space, who knows what else is out there waiting to be discovered? If you were an extremophile, which superpower would you choose? Heat resistance, freeze-proofing, or the tardigrade's invincibility? Let me know in the comments below. If you enjoyed this deep dive into biology's toughest survivors, smash that like button and subscribe for more journeys into the unknown.